All right. Shall we just get this show on the road? Everybody's here. Just begin. All right. Well, good morning, both of you, and everyone else watching later. What if you're not watching in the morning? And in fact, that's more likely than not. Good day just doesn't sound, it's the more general, but it just doesn't have the same punch. I need more syllables. Good morning, good afternoon, good evening even works, but good day is just too short. Somebody find me a longer word for day. Anyways, hello, welcome, I'm glad you're here. Today is going to be mostly a work day, and that is you are going to continue to practice adding and subtracting rational expressions. I almost lost the word there. I was about to say polynomial. I'm like, no, we're beyond polynomial. It's actually a ratio of two polynomials. And that's part of what makes it interesting is that we took two polynomials and said, what if we compare these, right? So remember back to, basics algebra, any ratio is really a comparison to two numbers. And so when you see these graphs, I'm just going to kind of spoil it for you a little bit here. That's the geometry stuff. There we go. When we get to the graphs of these things and you see, something take off like that, actually worse than that, right? Takes off to infinity. It tells you something about the ratio of like, hey, this, the top one is winning. It goes off to infinity. So you had, poly versus poly. Who wins, right? Do I take off to infinity? Do I stagnate at zero? Okay. Does the bottom one win? Actually, if the bottom one wins, right, this would take it to zero. Does it stagnate and like flat line at y equals 2 or something, right? I don't know. Right? It's a comparison between the polynomials. So if you want to see, which polynomial wins, that's what we're going to do. That's what we're going to plot. Next week, we will get to the actual graphs next week. Today, we need to practice. And before continuing with today's practice, I want to first go over the answers to yesterday's. And actually, I think we still have to do the multiplying and dividing. I never went over the answers there. So please take out your 9.1 worksheet. That makes this a very important video. I've got double the answers here. Okay. 9.1, here are the answers for multiplying and dividing rational expressions. And I will just slowly scroll through this and let you check those against your work. Stop me at any point if you have a question. That's a 6E, not a B. And they started to get a little wider. It's hard to get them all. Let's see, there we go. Okay. 18 almost got messy, but the factoring wasn't too bad there. I only say that because I've seen worse. Okay, and then here is the back side. Beauty of the recorded video is you can pause and go back to any point. All right, and then the word problems down there as well. If you are determining the length of the other leg of a right triangle, you are, of course, using Pythagorean theorem. So you're going to set up your, I'm sorry, because this is area, my bad, not hypotenuse. The area, area of a right triangle, 1/2 length times width, or base times height, whatever you want to say it. So this times something else, all divided by 2 will give us that. Okay, so you can work backwards to determine what this must be, in which case you'll take this, double it, and then divide by that. Literally by ratio, right? Divide those two. Then similarly with the pyramid, we have the area of its base, we have its height. So what would be the volume of a pyramid? Remember, a pyramid is 1/3 area of the base times the height. Okay? So you have to take this times that times 1/3, and that will all simplify to x plus 5/6. Okay, no questions from there? All right, then back to this one, 9.2. We start with the LCMs, which I don't know about you, I always think when I see LCM, I now am reminded of the AlgIIs from Toy Story, or more specifically from the Buzz Lightyear animated spin-off series. They constantly refer to them as the LGMs. The little green men. Right? Anyways, here's the least common multiples. A little bit less exciting. Okay. From 10 onwards, you had to factor them out yourself first. Can you do 15? Sure. Zoom on in there. Let's fresh color here. Can we do 15? So first we want to factor. So I'm looking at this. I'm saying 3, 18, 27. So GCF out the 3. X squared minus 18 divided by 3 is 6. 27 divided by 3 is 9, right? Yeah, 9. Okay. And do we have factors of 9 that... Wait. 9 is a perfect square. Is this a perfect square? Square root of 9 is 3. This is twice the product. What if it was negative 3? This could be 3 times x minus 3 squared, right? Negative 3 times negative 3 is positive 9. Negative 3x plus negative 3x, negative 6x. Yes, perfect. Okay, and then this guy, 2, 4, 6. Ooh, I want to factor out the 2. A nice big comma here to separate it. So that becomes, and everything's got an x, so 2x. And I'm left with x squared minus 2x minus 3 here. Okay, factors of negative 3 that will add to negative 2. So it's a very short list, right? Some combination 1 and 3. Those are the only factors. So if I make the 3 negative and the 1 positive, that'll add to negative 2. Yes. Okay, so 3 negative and the 1 positive. And this was a 1, so I can just go straight to answer format. Excellent. There we go. So the least common multiple will be 1 of every factor not repeating. So I need to use the 3. I need to use the 2x. 3 times 2x is 6x. I need to use an x minus 3. And it is there. And why has it got to be squared? So otherwise, it's not a multiple of this, right? It's got to be a multiple of this whole thing. So the only thing, like because this repeats within one item, it has to be repeated here. Okay, it's the same as like if this was 9, I would still need the least common multiple of 9 would include 9 as a factor, even though 9 is 3 times 3. I can't just be a multiple of 3. I got to be a multiple of 9. Okay, I got to be a multiple of x minus 3 squared. So it's just the fact that x minus 3 gets duplicated over here means I can ignore it and only be squared. I don't have to multiply again and be cubed. But then I do have to include the x plus 1 factor. We get that there. All right? Didn't write the x after the 6. Oh, yeah, you missed the 6 because the 2x, you got to factor out that x, and then it's here. Yep. It's always, right? Tiny little thing. This is why we practice. Now it seems ridiculous. Algebra 2 is, in my opinion, not so much about the here's new stuff. And it is. There's plenty of new stuff that builds on top of Algebra 1 and gets you ready for pre-calc and then calculus. But the biggest thing is just extra practice. Extra practice. So you start to eliminate those minor mistakes like that, or at least make them much less common. Okay? On to the next page. There were only 6 of them there, so we can get them all on screen here. You, of course, would use your LCM finding skills to find the LCD, least lowest common denominator, not liquid crystal display. And then add and subtract accordingly. Okay. Any questions here? Do number 5? Sure. We'll tackle number 5. All right, look at this. This is x minus 1. This is x squared minus 1. Hey, wait a minute. This is a difference of squares. It looks super simple, but I would rather have my factors be all linear terms than quadratic ones. Okay? Same thing over here. We've got a quadratic, so let's factor that guy out. It's not a perfect square trinomial. Wait, it is. Yeah, square root of 1 is 1. Double that is 2. So yes, this is x plus 1 squared. Ha ha. See, those special products coming in handy, right? Super easy factoring format. I might have to throw in another list the 7 rules of factoring question on this section's test, just to be sure, okay? You got to stay sharp on that. And then what happens? Now we need the actual LCD. So they both have the x plus 1. This has an extra x plus 1. This has an extra x minus 1. So we will multiply this side by the thing that it's missing, x minus 1 over x minus 1. And, excuse me, answer, you're in my way. We'll multiply this side by the thing that it's missing, which is an extra x plus 1 over x plus 1. Right? So because they already share an x plus 1, I don't have to multiply by the whole thing. You could, when in doubt, multiply one fraction by the denominator of the other, and the other fraction by the denominator of the first. Okay? Do the whole thing, right? You make your fufu be entirely the denominator of the other fraction over here. You'll quickly have a few factors that should reduce out right away. I'm basically skipping that step, right? I could have done x minus 1 times x plus 1, right? We could do that. That will work, except this guy will immediately reduce with one of those. And, well, now I've been, right? So, doesn't make a difference. So what happens on the denominator? We get 1 of everything, or in the x plus 1 case, we get 2 of them, and an x minus 1. And in the numerator, we have a much bigger line here. Right. X minus 1 times 3x. Oh, come on. Oh, we can factor that. That's just 3 times x plus 1. Geez. Right? Oh, well, now that I see that, we can simplify it even further. Wow. Okay, let's do the multiplication, and then we'll simplify. Let's keep this, though, as 3 times x plus 1. Oh, look at this. Plus x minus 1 times x plus 5. Okay, because it only eliminates if it's in both of them, right? So this has x minus 1, this has x minus 1, so I can eliminate it from here. Okay. This has x plus 1, this has x plus 1, I can eliminate one of those from here. And take off that. And so now what is left up there is only the 3 plus, I eliminated those, everything is multiplied by an invisible 1, so it's 3 plus 1, aka 4, and the only thing in the denominator is x plus 1. Okay. Looking at this, could we have simplified other stuff sooner? Sure, absolutely. It all depends on when you see it, right? We could have done that, said, hey, this doesn't even need the x minus 1. I don't even need to multiply by this on this side. This could have eliminated right here, right? And that would have taken us straight to, they would have had the common denominator from the beginning, okay? But that's the beauty of hindsight, right? You realize, oh, I should have seen this sooner. Yeah, could have saved yourself some time, but it still works. Okay, there you go. Final call for questions? No more? All right, then you have the rest of the 9-2 practice worksheet for today. Go ahead and start on that. Let me know if you run into any trouble. It is more, just more of this, right? Just build those habits. Try to see if you're like, hey, find those things like the shortcuts like I did here in green. Oh, geez, if I could have seen that first, I should have done that, right? That's why we practice more. So there you go. Have at it. We'll wrap up the YouTubes here.